What your program is divided into process. Okay, means suppose you are having snd dot c. This is your program. So this program will be divided into number of process. Suppose p1 and p2. Now the process will be divided into the thread. Okay, means you are having process p1 and p2 in a program xyz. So that process p1 will divided into the thread. That is a basic unit of CPU utilization. So we can see here in the diagram. So this is your process, and in that process there are multiple thread. Thread 1, thread 2, and thread. So these are the three types of thread in a process. Okay. Thread is a flow in execution. Thread is a flow in execution. Process is what? Program in execution. Process is nothing but the program in execution. Thread is a flow in execution. Then a thread is a contained inside a process, and different thread in the same process share some resource, most commonly memory, while different process do not share the memory. So this is the difference. In suppose in your program we are having process p1 and p2. So p1 and p2 will not share the memory. Process do not share the memory, while thread share the memory. So this is one first difference between process and thread. So here in a diagram you can see T1, T2, and T3. They will share the memory. So they are having the process P. We are having process P. So it is sharing the. It is a containing number of threads. So these threads are sharing the memory, while process do not share the memory. Okay. So TCP, thread control block, while process is having what? TCB, process control block. So your thread is again having what? TCB. It is a basic unit of CPU utilization. It comprises a thread ID, same as your process ID. Process TCB is having your process ID. Now thread will have what? Thread ID, then your program counter, register state, and stack, same as your TCB. Instead of P, we are going for TCB. Okay, process and thread. Now, what is thread? A thread is a flow of execution to the process code with its own program counter, system registers, and stack. So now each and every thread will have its own memory. It will have its own memory, then program counter and registers set. So what happens here? They can share the T1 and T2 can also share the memory, but each and every thread will have its own memory also. Sharing is possible in a thread, that is not possible into the process. Then second, thread is a thread is also called a lightweight process, while process is a heavyweight process. Okay, thread is a lightweight, process is a heavyweight. So thread is also called as a lightweight process. Thread provides a way to improve application performance to the parallelism. Is what? Simultaneous execution, that is called as a multi-threading. That is called as a multi-threading. Means what? Concurrent execution of thread is possible, or parallel execution of thread is possible. So that will improve the application performance. Each thread belongs to exactly one process. No thread can exist outside a process. So each and every thread will process will have the thread. Means sharing of the thread is means P1 will not consist the thread of P2 process. Okay, that is what that process will have their own thread. No other threads can be exist for that process. Then each thread represents a separate flow of control. Threads have been successfully used in implementing network servers and web servers. Threads have been successfully used in implementing network server and web server. They also provide a suitable foundation for simultaneous or parallel execution of application on a shared memory multiprocess. Means suppose you are having process P1, it is consisting of thread T1, T2, and T thread. If you are having multiprocessor, three processor, then T1 can execute on processor 1, T2 can execute on processor 2nd, and T3 can execute on processor 3rd. So simultaneous or parallel execution can be possible in a threading, that is a multi-threading. So this is the difference for each and every question paper. This question is asked: what is the difference between process and thread? So what is the difference between process and thread? Process is a heavyweight. I have said it before. Process is a heavyweight or resource intensive. Thread is a lightweight, taking less resource than a process. It requires more resource. Thread requires less resource, so it is a lightweight. Second difference is process switching needs interaction with OS. Process switching need, you have studied the context switching. So in that is we are using the process switching. So what is the, we require the interaction of OS, while thread switching does not require the interaction of operating system. They can switch because the threads are available in that process only. So they can switch between their process. Means what happens here? Second difference. Suppose we are in a class T class. Okay. Now what happens in T class? So this is a T class is what? Your process, and the student are your thread. So switching between your branches, changing the branches, it is a simple one. They do not require any permission. But that is not case in a process. Means what in process they are A and B are two different class. So if you want to go in B class, it require the permission of HOD, for example. So this is what interaction with OS. So that is a process switching needs interaction with OS, and this does not require the interaction with OS. In multiple process environment, each process executes the same code but has its own memory and file resource. All threads can share same set of open file and child processes. Means here what sharing is possible, and in process they do not share the memory. So that is the third difference. If one process is blocked, then no other process can execute until the first process is unblocked. Means your memory. Suppose P1 is hold the memory. Until it will release the memory or it finish the execution, second process cannot execute. While in thread, if any thread is blocked or waiting, second thread can thread in a same task can run. So this is what fourth difference. Fifth one is multiple process without using thread use the more resources, and in multiple thread uses fewer resource. In multiple processes, each process operates independent to the other. Means they will execute, P1 will execute without depending on second. One thread can read, write, or change another thread data because they are using in the same memory. So these are some difference between a process and thread. So this is a structure, single and multiple thread or multi-thread. We have seen here single threaded process and multi-threaded process. So this is your thread, okay, and it consists of code, data, file, registers, and stack. So this is one thread for P1. So we can say P1 process P1 is considered only one thread. The second process is your P2, that is considered how many thread? 1, 2, and 3 threads. So each thread will have its code, registers, and stack. Then data register and stack, file register and stack. Now what happens here? You can see this thread is having code, this thread is having data, and this thread is having files. So we can share, means this thread can share the data, this thread can share the code, this thread can share the file. So what happens here? They are sharing the memory. That is not possible in a process. So this is a multi-threaded process consisting of more than one thread. This is a single-threaded process. Okay. A single thread has a single thread of control. It allows the process to perform only one task at a time. Multi-threaded has many threads, simultaneous execution of different tasks. Okay, threads are divided into the tasks. I explained last lecture. Thread is divided into the task, and task is what? A set of instructions. So multi-threaded has many threads, simultaneous execution of different tasks. What is the benefit of thread? What are the benefits of thread? So first one is your responsiveness. Second one is your resource sharing. Third one is economy. Last one is your scalability. So what is responsiveness? Allows the program continue running if a part of it is blocked or it is performing a lengthy operation. Means program can run. Suppose the thread is lengthy thread or any thread is blocked. Till that process can a program can continue running. It is a responsive. Second one is a resource sharing. So I explained in the previous slide, threads share the memory and resource of the parent process. Economy in Solaris, creating a process is a 30 times slower than creating a thread. Context switching is 5 times slower. For what process? So thread required less time for creation and for switching also. Okay. So in just given the example in Solaris, creating a process is 30 times slower than the creating the thread. Means what happens here? Thread requires 30 times less time than process, and context switching for process is 5 times slower or than thread. So it is what beneficial economy. And last one is your scalability. Multi-threading on multiple CPU machines increase the parallelism. Means what happens here? Suppose you are having 5 thread, you are having 5 CPU processor. So 5 processor thread can execute simultaneously on a 5 processors. So this is what scalability. If any processor fails, that thread can execute on another processor. So simultaneous execution is possible. So these are some benefits of thread. Now user level thread and kernel level thread. So we are studying what is user space and kernel space. So threads which are in a user level or the user space is called as a user level thread, and the threads which are in the kernel space. So what is the kernel? All the operations are performed by the OS with help of kernel only. So now here we can see user level thread and kernel level thread. So this is your user level and this is your kernel level or kernel space. User space and kernel space. In user space, user can interact with all the operation in a user space, but user cannot interact with the kernel space. So which are operations are related to kernel, user cannot interact with that kernel space. So you can see here, so this is your process, circle is your process, and these are the threads. Okay, 1, 2, and 3 threads are there, and this is the second process in which there are 4 threads. Okay, then runtime system. So this is what, and thread table. Table means your thread control block will be here, or all the information of thread will be here in the thread table. Then kernel space. So this is your kernel space. There is no any thread. Okay, and here is your process table. Okay, process table. While in the kernel level thread, you can see the difference. Here is your thread table. Okay, you can see here. Here is your thread table. Threads are in a user space. But your thread table is where? In a kernel space. While in the user level, table is here in your user space. In the kernel level thread, table is in a kernel space. Thread table is in a kernel space. Okay. So that is user level threads are in user space. Kernel level threads table is in a kernel space. So user level threads, a thread management done by user level threads library. It consists of thread creation, scheduling are done in a user level, fast to create and manage. Okay. Drawbacks: if the kernel is a single thread, then user level thread perform is blocking system calls, which cause entire process to block. So that is the disadvantage of our user level. Means the thread get blocked. Means user level thread get blocked. So it we have to wait for more time till that thread get unblocked. Kernel can, if it is a kernel can easily unblock that thread. But in user level thread, user cannot unblock that thread, so that system will go in a blocking state. And the advantage is what? It is fast to create and manage. Kernel thread supported by OS, thread creation, scheduling are done in user level by the kernel. This kernel will interact. All the activities are carried out by the kernel only. Whether to create, delete, modify, whatever operation that is done by the kernel. Thread management is performed by the OS, thus kernel thread is slow. If thread performs blocking system call, kernel can schedule another thread in an application for execution, which was the disadvantage of user level thread. That is the advantage of kernel level. Means it can easily create the another thread and that can execute. Okay. Now next point is a multi-threading model. More than one thread is executing. So in that there are many to one, many to many. So these are the types of model, multi-threading model, many to one to one, and many to many. So this is the first one, many to one. So first one is a multi-threading model is your many to one. So here many user level threads map in a single kernel thread. So here you can see in the diagram, these are the user thread 1, 2, 3, and 4. While only one is there, kernel thread. So this is mapping many to one. Examples are Solaris green thread and GNU portable threads. So these are the examples of many to one, in which more than one thread is your in a user space and only one is there in a kernel level space. So this mapping is many to one. Then one to one user level and one kernel level thread. So each user level thread maps to the kernel thread, allows another thread to run if block, allows another thread to run if a block. Means suppose this thread gets blocked, the second thread can execute. Run parallel, so this fourth thread can execute simultaneously. Drawback, along with user thread, kernel thread should be created. Means when your user level thread is created, at that time we should create the kernel level thread should also be created. That is the disadvantage or drawback of one-to-one model. So example is in which Windows NT XP and 2000s are using the one-to-one thread model. Linux is also using one-to-one thread model. Then many to many. Many user level thread interact with many kernel level thread. Allows many user level threads to be mapped to the many kernel level thread. Allows the operating system to create a sufficient number of kernel level threads or kernel threads. Example is your IRIX, HPUX, 264 Unix, Solaris 8 and earlier versions. So they were using the many to many kernels. So you can see in the diagram 1, 2, 3, 4. Many user threads are executing with many kernel threads. Okay. Now next point is your multi-core programming. Means multi-core means more than one processor. Multi-core programming. Multi-core system putting pressure on programmers. Challenges includes dividing activities. Means that activity should be executing on a multiple processor. So we have to divide that activity. Dividing activities. Find the area that can be divided into separate concurrent tasks. Then balance. Second one is the balance. It ensures concurrent tasks perform equal work of equal value. Suppose you are having two processors, you are having two process. So that two process can execute on a two processor. But if you are having five processors, two processors, how to balance? Means which task is repository for one task require one process require 1 hour, one require only 10 milliseconds. So how to balance should be done. So which process should execute on a which processor? So that is again the balancing should be done. Then data splitting, data access must be divided to run on a separate code. So whichever data they are accessing, that should be properly divided on a separate code. Data dependency, one task depends on a data from another, ensures synchronization. So there must be proper communication. Suppose your task, one task requires the output of second task. So that task should be executed first and then the output should be given to this first task. So there must be proper communication and synchronization between the task also. So data dependency, because the result of first task is dependent on a second task. So that purpose, there must be proper synchronization between the process of task that are to execute on a multiple processor. Then next one is the testing and debugging. Test many execution path. Means each and every part should be tested. Some parts should not be, or some parts should not be remain untested or debugged. So debug. So here testing many execution part means each and every processor should execute all the parts of your processor program. Now listen here, concurrent execution on a single core system. Single core means what? Single process. What happens single core? T1 execute, T2 execute, T3 execute, T4 execute. Means suppose you are given the 10 millisecond time for each process. 10 millisecond. After 10 millisecond, this process T1 will get interrupted. T2 will execute. T2 after 10 milliseconds finish. T3 start. T4. Then T4 start. Again, the chance of T1 comes. Likewise, this is what single core. Okay. While in a multi-core, simultaneous execution is possible. Core 1 and core 2. So core 1 is T1 is executing that time. T2 is executing on a core 2. T3, core 1, T4, core 2. Again T3, T1, T3, and even likewise, it will continue. So here is what multi-core, more than one processor is one processor executing simultaneously. Now this is a thread library. Some libraries are available in the operating system, which are useful for the programming purpose. So which are the thread libraries? You know, different types of thread libraries in the operating system. So thread libraries provide programmer with the application program interface for creating and managing the threads. So inbuilt libraries are available in the operating system for your creating the application program interface. So two primary ways of implementing library entirely in a user space and kernel level library supported by the OS. So some libraries are defined in a user space while some are defined in a kernel space. So two primary ways of implementing. So three main thread libraries are available in operating system. First one is a POSIX thread, POSIX speed thread. Second one is a Windows thread, and last one is a Java thread. So Java thread library is Java program. POSIX thread is provided either user level thread or kernel level thread. Okay, these are the inbuilt libraries which are provided in a user level thread or kernel level. That is a POSIX thread. Okay. Second one is your Windows. The Windows thread library is kernel level library available in the Windows system. So this is kernel level. POSIX is user level or kernel level. Windows is your kernel level. And third one is the Java. Java Threads API allows threads to be created and managed directly in a Java program or Java virtual machine. So that is regarding to the Java API. Java threads are available in a Java. Now this is the main part in programming. When you execute any program, so we require the P thread, classes of P thread. So that is a P thread. Means suppose you are executing any program, client server program or your consumer producer program, any program in a Linux operating system or Ubuntu, we require this class P thread. So may be provided either as a user level or kernel level POSIX thread, P thread. P thread is a POSIX thread. The POSIX standard IEEE 1003.1c API for thread creation and synchronization. Okay, P thread is which one? POSIX thread, which is developed by our standard IEEE 1003 for creation and synchronization. API specifies behavior of thread libraries. Implementation is up to the development of the libraries common in Unix operating system, Solaris, Linux, and Mac OS 10. So these are used in a Unix. These are used in a Unix operating system. Now, thread pool. So what is a thread pool? General idea behind the thread pool is to create a number of threads at a process startup and place them in a pool where they sit and wait for the work. So that is called as a thread. Once multiple threads are created and put in that pool and wait for execution. Whenever they get chance for execution, they will execute. So that is called as a thread pool. When the server receives a request, it awakens a thread from this pool. If one is available and the passes the request for service. If the pool contains no thread, then the server waits until one becomes free. Whenever that pool is empty means no threads are available. If pool is having multiple threads, then the server will call that this thread is required, that thread can get the access. So that is the use of thread pool. What are the benefits of pool? Servicing a request with the existing thread is faster than waiting to create the thread. The thread pool limits the number of threads that exist at one point. Multiple threads can be made available. Separating the task to the perform from the mechanics of creating the task allows us to use different strategies for running the task. The simultaneous execution can be possible. More threads are created, they can easily access. So this is a thread pool. Limits the number of threads that exist at any one point. This is particularly important on systems that cannot support a large number of concurrent threads. So here what this function runs on a separate thread. So we can easily select the thread from that pool and we can execute anytime. A pointer to a pool function. So here is passed to one of the function in a thread pool API and thread pool execute this function. So here is a pointer to the pool function. We are using this pool function to get the access to that pool. One such member in a thread pool API is a queue user work item. So in using this one, queue user working item or work item. So this is used for getting the access to the thread pool API. Now thread pools queue user work items function which passes three parameters. So what are the three parameters for thread pool queue items work item? First one is a LP thread start routing function, a pointer to the function that is used to run a separate thread. Then P void the parameter passed to the function param is a parameter, and last one is a ulong flag. Flags indicate how the thread pool is created and manage execution of the thread. So these are the three parameters which are passed to the queue user work item function for getting the thread from that pool. So multiple threads are created and put in that pool, and that getting the using this function we can get access to that thread using these three parameters. Then what are the drawbacks or issues in threading? First one is your so two types of system calls are required: semantic of fork and exe execute system calls. Now, what is use of fork? Fork is required. This is system call. Fork and exe is a system call. Fork is used for creating the child process from the parent process. Okay. Now, how to the parent process will create the child process. So, how to specify semantics? Which function or which syntax should be used for creation of fork, the child process, and the execute system call. The second one is a signal handling. Suppose a thread is running. Now there are multiple signals coming. Means your interrupt may be occur. The thread can be interrupted. So the whichever signal is same. So whichever signals comes for the thread. Means if your thread life cycle is suppose you are having process life cycle, there is also a thread life cycle. Created, executing, terminated, zombie state is there, then interrupted. So whichever signal comes, so how to handle that signal, that is a signal handling problem. Then thread cancellation problems are there. Then scheduler, local storage, and scheduler activation. Scheduler, local storage, and scheduler activation. So these are some issues. Thread cancellation, how to cancel the thread or terminate the thread. Process can easily, means using fork we can create the child process, and using kill we can kill that process. So that is simple one. Since you are using in the process, while in thread, suppose that thread is created, how to cancel that thread? That is the main issue. Then scheduler local storage, and last one is the scheduler activation. Onira.